Alright, so I think I'm recording. We're taking a look at our skill packet number 3, which is the relations and functions. And in skill 3E, we are looking at the combination of two functions. We're looking to build a new function using two old functions through addition, subtraction, multiplication, and then eventually division and function composition. We're also asked if once you find this new function, or maybe you don't have to find the new function, but what's the domain of the new function? So here in problem number 7, hopefully you'll find this pretty easy, because the domain is the set of all real numbers, excluding any values that cause division by 0. We don't have a variable in the denominator, and also excluding any values that cause us to take the square root or even root of a negative number, and we don't have any square roots here. So our domain for f is all real numbers. And by the same reasoning, when you look at g, hopefully you recognize that the domain of g is all real numbers. So to be in the intersection, to find the domain of f minus g, you have to be a member of both sets. Well, all the numbers are in both sets. So if you probably don't even have to draw the picture, but sometimes that helps. We're trying to find the domain of f minus g, and we know that you find it by intersecting these two sets, and the intersection is reliant on our interpretation of the word and, that you have to be in the domain of f and you also have to be in the domain of g if you're in the domain of the intersection f minus g. So my domain of f is all real numbers. My domain of g is all real numbers. So all of the numbers are in both sets, so therefore they're in the intersection. And we find this problem, hopefully you found it easy, that the domain of f minus g is a set of all real numbers. Let's go ahead and do the next video on this since this one was easy and short. Okay, so we're not quite going to be quite so lucky here. Domain of f is the set of all real numbers, and we don't have a variable in the denominator, but we do have a variable underneath an even root, underneath a square root, and that has to be 0 or positive. So our domain is all real numbers that are greater than or equal to -1. When we look at g, we don't have any square roots, so we don't have to worry about taking the square root of a negative number, but we do have a variable in a denominator, this x minus 3. We have to avoid it being x being equal to positive 3, because 3 minus 3 will cause us division by 0. If you try to evaluate this function at 3, you'll get 1 divided by 0, and that's undefined. So 3 is not related to any y value, therefore 3 cannot be in the domain. So let's draw a picture of each of these on a number line. So for the domain of f, -1 is to the left of positive 3, and then for the, well, let's go ahead and we can, to be greater than or equal to -1, well, to equal -1, that's a solid dot. For x to be greater means to the right, so all of these numbers to the right, they're in the domain of f. Now let's draw a picture describing the domain of g. The domain of g, the number simply can't be 3. Anything else is okay. So we've got almost all real numbers. Any number you can imagine except one value, 3. That's the only one that causes division by 0. So to be in our answer of this new function that you get by adding them together, to find the domain of it, to find the domain of f plus g, we intersect the domains of f and the domain of g. So to be in this intersection of the two sets, you have to be in both sets. So let's take a look at negative 1. Negative 1 is a member of the domain of f, and negative 1 is a member of the domain of g. So it is a member of the intersection, that it is a member of the domain of f plus g. Well, 3 is in the first one, but 3 is not in the second one, so 3 will not be in the domain of f plus g. To the left of negative 1 is not in both sets, so it will not be in here. But numbers that are between negative 1 and positive 3 are in both sets, so they will be in the intersection. And numbers bigger than 3 are in both of these sets. So if it's in here and it's in here, it'll be in the intersection. That's that idea of and. So now we need to describe what I've shaded in green, because that's going to be our final answer for the domain of f plus g. So it has the smallest number, negative 1, and negative 1 is in the domain, but 3 is excluded from the domain, but all the numbers that are larger than 3 are in our domain. So there's our answer for, I believe I did 7 and 8 on the same video. So I hope that helps, and I'll talk to you later.